Alright, let's continue with subtopic 19.8, magnetic force between two parallel conductors. In wire 1, there, let's say, will be current flow. This is I1 flowing to the right. Okay, in wire 2, okay, another current flow, okay, symbolized as I2. Right. So now in order to determine the force experienced by each of the wire, we need to predetermine the B produced by each of the wire. For I1, okay, place your thumb along the direction of the I1 and grabs wire 1. So the bottom part of wire 1 will be B1 into the page. Okay, on the top of wire 1 will be B of it out of the page. So the blue color here is B1. Right. For B2, okay, place your thumb along the I2 direction and then grabs the wire. So you will have, okay, B2 at the bottom of the I2 or wire 2 will be into the page. Okay, however, on the top of it will be out of the page. So the orange color here is B2. Okay, so now to consider the direction of the force experienced by the each of the wire here. Okay, so the general equation is F is equivalent to BIL sin theta. Right. So the L is the length of the wire. Okay. The theta is the angle between the I, the current, and the B. So if you see here, the B and the I is perpendicular to each other. Therefore, it's C90. Okay, C90 here. So C90 here give us value of 1. So we are left with only BIL sin theta. To calculate F experienced by wire 1, okay, so we put F1, okay. Of course, the formula will be BILL1, alright, which is happen to be the same L to L2. But I is I1, B must be considered is B2. Why is it? Because the B2 is the one that going to cause the effect or cause the force experienced by the wire 1 here. Okay, the B1 produced by wire 1 by itself does not affect anything on itself. Okay, on wire 1 itself. Okay, the one that going to affect, that one cause the force experienced by wire 1 here is B2. Right. So this is in terms of calculation. So in terms of further of B surrounding wire 1 B2, in other words, is mu naught I2 over 2 pi r. R is the distance between center to center between the wires. I1 L, because L1 is equivalent to L2, or simply L. Alright. So this is the magnitude of F experienced by wire 1. Okay, caused by wire 2 or B2. Alright, so the direction now, let's try together. Let's recall the right hand rule number 1. Place your index finger in the direction of the current 1. okay, the B in according to B2, because we are considering wire 1, so B2 must be the one that caused the force. Okay, then put your index finger along I1. B2, okay, is out of the page, okay, so the force will be downward on wire 1. The force experienced by wire 1 will be downward like this. This is F experienced by wire 1. Alright, so now we're going to proceed for direction calculation or magnitude of F experienced by wire 2. So F2 is equivalent to B1. Which one? B1 or B2? B1. Because B2 does not give any effect to its own wire. Right? So I2 is flowing within wire 2 and L. Right? So the magnitude of it is mu naught I1 over 2 pi r, okay, I2L. So my dear, if you refer to this, okay, if you refer to this, this one and this one, they are the same, isn't it? So means that magnitude of F1 is the same to the magnitude of F2, but they are opposite or the same direction. Let's try about direction. Okay, so direction of F2, F experienced by wire 2 due to B1. Alright, place your index finger in the direction of I2. Okay, and then rearrange your the rest of your 4 fingers according to B1. B1 within the area of the wire 2. Okay, B1 is blue color, which is into the page. So I index finger along I2. B is into the page. Okay, B2, yeah. So your thumb is pointing upward. Okay, your thumb is pointing upward. Right. So the F experienced by wire 2 will be upward like this. It seems like, it seems like F1 and F2 attracted towards each other. Okay, it seems like it's attracted towards each other. So we can have a term of some sort of attractive force between them. The magnitude of them the same, but they are in opposite direction and they act on different object or wire. So you cannot sum between F1 and F2. Cannot be done because they are acting on different wire, like Newton's third law. Okay, action reaction. So you cannot have F1 plus F2. No. Okay, because F1 acting on wire 1, F2 acting on wire 2. They are acting on different objects. Right. But in terms of net magnitude, they are the same. So means that you only calculate once. Okay, they should be the same in terms of magnitude. So between two parallel conductors, okay, if the current flowing in the same direction, okay, there will be force, okay, acting on each of the wire towards each other. Seems like the force is a kind of attractive force. The magnitude of the force is the same, but they are in opposite direction. They cannot be add up, okay, or subtract between them. You cannot have mathematical treatment between them because they are acting on different wires. Right. Next one, this is similar approach. This is diagram given in your text. I put it here. Okay, if the question asking for force per unit length, so you're going to put F over L equivalent to mu naught, okay, mu naught I1 I2 over 2 pi R or D according to this drawing lah. Remember, R or D must be from center to center between the wires. Okay, so the unit of your force must be in Newton, the length must be in meter, the current, both of the current must be in ampere, and the D must be in meter. Every single thing must be in SI unit, yeah. Right. How about, okay, if the arrangement is like this one? Alright, so this is actually, this one, okay, figure A here is actually similar to the one that Madam discussed with you just now. Okay, it's just that the alignment in terms of they realign the position of the wire, yeah, right? So now for this case, how come the force like this? Alright, because this is consequent of the I1, I2 are in opposite direction. So let's predetermine on how to have this direction. So again, what you're going to do, you're going to sketch the B produced by each of the current. So let's begin with B1 produced by I1. Right. So by using Grepp's rule, place your thumb along I1 to the top of the screen. Alright, grabs the wire 1. On the right side of wire 1, there will be B1 entering the screen. Like this. This is your B1 right side of wire 1. On the left side of wire 1, B1 will be in this direction. Okay. So, to consider the force experienced by wire 2, okay, we are going to use right hand rule number 1, okay, where you are going to place your index finger along I2 direction to the bottom of the page. Then you will place the rest of your 4 fingers according to the direction of your B1. Alright, so place your index finger to the bottom. The rest of the 4 fingers is into the page, okay, and your thumb is pointing to the right, isn't it? That is why the force here is in the direction of this. So this one is F experienced by wire 2, right? So next one is the force experienced by wire 1. Okay, so we need to predetermine or sketch the B produced by wire 2. Right, place your index finger along, okay, along direction of I2, grabs your conductor. Right, so you will have, okay, on this side the B2, okay, will be into the page. Okay, and this side B2 will be out of the page. The orange color here is B2. Right, so F experienced by wire 1, right, F experienced by wire 1 here, okay, we're going to use Fleming right hand rule number 1. Place your index finger along I1, consider the direction of B2. Alright, so I1, your index finger is along I1, your B2 is into the page, so your thumb is pointing to the left. That is why your direction of F experienced by wire 1 is to the left. So this is F experienced by wire 1. So in conclusion, what can we say? We can say that whenever there are two parallel conductor, long straight parallel conductor like this, okay, having current flow in opposite direction, alright, the force experienced by the wires will be in opposite direction. Their magnitude is the same, however, in opposite direction. But if you have two long straight conductors having current flow within it in the same direction, so the force experienced by the conductors will be in the opposite direction and kind of attractive force. This one will be repulsive force. This is attractive force. Okay, the magnitude of the force will be the same, but their direction will be in opposite direction. Okay, magnitude is the same, and bear in mind you cannot have addition or subtraction process between the forces because they are acting on different wire. So let's again do some of the calculation or proving that the force is the same. Let's say I consider figure B, okay? So F1, okay, B, I, L. Sin what? Sin 90 degree. Why 90 degree? Because the B and the I is perpendicular to each other. So this one becomes 0. So which B to be considered if it is F1? B2. Which I? I1. Right. So for F2, B1, I2, L. Okay, again the same, sin 90 become 1. So, what is B1 and B2? Okay, B2 is mu naught I2 over 2 pi R I1 L. This one also, mu naught I1 over 2 pi R I2 L. So, the magnitude of F1 and F2 is actually again the same, regardless the direction of the current. Okay. So, this is exercise taken from your textbook, question number 58. Right, question number 58. Right. In figure, the current in the long straight wire is I1 equivalent to 5 ampere. And the wire lies in the plane of the rectangular loop, okay, which carry of 10 ampere. The dimension shown is C equivalent to 0.1, A equivalent to 0.15, okay, and L equivalent to 0.45 meter. Find the magnitude and direction of the net force exerted by the magnetic field due to the straight wire on the loop. Okay. So first thing first, what's requested in this question? Find the magnitude and direction of the net force exerted by the magnetic field due to straight wire on the loop. Right. So the one that causing the force is the long straight wire, I1 or B1. So by using right hand rule number 2 or Grab's rule, first thing first, we need to determine the B produced within long straight wire 1. Okay, so place your thumb along I1, grabs wire 1. So you will see, okay, B produced on the right side, okay, of wire 1 will be into the page. Okay, on the left side will be out of the page. Okay, so this is B1. Right. So now, okay, we're going to consider the force, the direction of the force, okay, experienced by each of the side of loop, okay, given here, rectangular loop. Alright, so let's consider this side first. Okay, alright. The rule that we're going to use is right hand rule number 1. Place your index finger along I2, okay, and the rest of your 4 fingers according to the B where the loop is immersed or placed. Okay, so your index finger is to the top of the screen, your B is into the page. Alright, the force will be to the left. Okay, the force will be to the left. Right, so the force on this side is to the left direction. Okay, next one, okay, will be for this side. Okay, the current flow within this side will be downward, right? Okay, this is the direction of the current flow. Okay, so place your index finger along I2 that flowing within this section, okay, which is to the bottom of the screen. Alright, then your B is into the page. Your B is into the page. So your force or your thumb is to the right. Okay, your force will be to the right. This is the F on this side. Right. Then how about the force experienced by the top and bottom side? Right, so place your index finger along the current flowing within this side. Your B is according to this one. Alright, so it will be to the top of the loop. This one. Right, and then again repeat the same process for this side. Place your index finger along the I flowing within this section, okay, which is to the left, and then place your forefinger, the rest of your forefinger according to the B here, which is into the page. So you will have the force experienced by this section is to the bottom. It means that, okay, the position as well, right, the position of this and the position of this will be the same. So the magnitude of the B produced here, F the produced here or experienced here, will be the same, because F is equivalent to B I L. Sin 90 in this case, why 90 degree? Because the current and the B is perpendicular to each other, so it's become 1. Right, so now if you substitute here, let's say this is the bottom and the top section, okay, of the loop. Okay, B1 I2 L, the L is the same. Then B1 itself, mu naught I1 over 2 pi R, and then I2 L. Okay, it's the same, isn't it? So if you refer here to the R here, will be this one, right? C plus half A. Here also C plus half A. So it's the same. One of it to the top, one of it to the bottom. So if we do summation in terms of y-axis, component of forces, okay, then you will get 0 amount. The net will be 0. So the one that different is the right side and left side of the loop, right? Because the position, the distance is different. For this one, it's only C. For this one, C plus A. Of course, the strength of the B will be different. Then the F also going to be different because it's depending on the B. Okay? And the I is the same for sure lah, because it's within the same loop. Right? So, madam going to continue with the calculation of the F at the right side and left side of the loop. Okay, so the F net going to be, okay, one of it pointing to the right, one of it pointing to the left. Let's consider to the right as positive. So the F net experience experienced by the loop will be, let me put it F1, here is F2. Okay, so will be positive of F1 plus negative of F2. Right, so what is F1? F1, by using this general equation, F1 is B1 I2L, right, plus negative already, B1 I2, this is B1 I2, this one B1 prime, because the position is not the same. The B will be according to the R. Okay, at this position the R is C, so this is B1. Okay, but for this side the R is already C plus A. That is why madam put the prime sign representing the R is different. Okay, then I2L. Right, so let's open up. Mu naught I 1 over 2 pi, what is the R? It's C, I2L, minus mu naught I1 over 2 pi, it's C plus A, I2L. Right, so we can have mu naught I1 repeated things, I2L over 2 pi, okay, bracket 1 over C minus 1 over C plus A. Then you can solve it. By right, you're going to get the answer is 2.7 times 10 to the power of negative 5 Newton to the left. Right? To the left. Why is it to the left? If you refer to this and this, which one is nearer to I1? The source of the B1. This one, right? Because the distance only C. The F is inversely proportional to the R. So, the smaller the R, the bigger the F. Okay? So, this F will be smaller in amount. Okay? So, the one that bigger is this one. So, this one going to be dominant. That is why the resultant following this one direction. Okay? Hopefully, you can clearly understand what I'm talking about. If you have a further question on this, please do not hesitate to consult me. Alright, that's all for this part or subtopic. Thank you.